Aron Ra, Part 2.
So let's start from evolution. What can you tell me? What do I need to know?
Well, the easiest or the simplest concept to explain in evolution, I think, where it's not the simplest, but the most basic concept to explain about evolution would be genetic drift. You understand that in every litter of puppies, in every pod of eggs by every frog, every one of these embryos has a certain number of mutations different than all of its other siblings. The only time you're going to get a genetically perfect match is when they're twins, and so that's one zygote that gets split in half. And so as cells replicate themselves or duplicate themselves later on, they run the chance of further mutations. But the ones that we're concerned about are the ones that you have from the moment of conception, the zygote. You have a certain number of mutations that you have inherited, and so these mutations can be acquired only when they occur in replicating genes in the parents that happen to be gamete cells. The parent gene pool tends to restrict new variants. It tends to hold everybody together. But if you divide that population, take a smaller group and separate them aside, and there's other ways to do this than just this, then you'll notice unique mutations appearing in the new group that in generations will proliferate throughout that new group, so that it pretty quickly, in just a few generations, you'll be able to identify whether a new organism came from that group or came from the original group. See, Darwin figured out natural selection, but he couldn't figure out genetic drift. He had no idea about genes. It was Mendel who figured out Darwin's mystery. Darwin had no way of explaining this. Mendel figured it out. Some people have termed Darwinism to be the original idea that Darwin suggested, which is natural sexual selection, and then they coined the term neo-Darwinism for the Mendelo-Darwinian synthesis of natural selection with genetics. But now they've changed the name again, and have just completely abandoned the use of the word Darwinism at all. So it's now the extended synthesis. So if you understand that the genetic drift happens, and it's inevitable, it's going to happen, and the only way to slow it down is by having a larger parent gene pool. The smaller the gene pool, the more rapid you're going to get, and the more likely you're going to get variation. Although that can still occur anyway. There's 4 different types of speciation. Some of them can occur within the even large parent gene pool, but these have a tendency to restrict. So when you get speciation is where you now have one that is completely genetically isolated, at least when we're talking about sexually reproductive animals. You've got something that where one genotype has become 2, then becomes 4 and 8 and 16 and so forth, except for the ones, of course, who go extinct. And then when you have a handful of them that have gone extinct, you find the original set may still be alive, and you have a couple of different daughter sets. It may be difficult to find exactly how closely related they are, but you can still test that genetically. So I have recently been invited to go to I'm going on a paleontological expedition into the Karoo, which is a remote wilderness region of South Africa. And I have confirmed there are lions and rhinos and that sort of thing in this area. So it's going to be the actual African experience.
Wow.
Yeah, but I'm going to be out there like in a pup tent for 2 weeks. We're looking for Permian therapsids. We're in an area where the Permian rock is exposed, where most of the therapsids that we know of in the world have come from. And I've talked to a number of the scientists that have already been there, and they're bragging about the individual unique species that each of them has personally discovered. A couple of them are impressive, up to 9 feet long. And I'm looking forward to the remote possibility that I myself could discover a as yet unidentified species of Permian therapsid. The Permian history is just prior to the age of the dinosaurs. That's at a time when there were still eurypterids and trilobites, and when we had proto-mammals, not actual mammals yet, but we had things that were closer to mammals definitely than any other type of reptile. If you'd seen them, you would think that they were mammals. You would call them mammals, even though they don't meet all the criteria yet. So the series of transitions between what Carolus Linnaeus would have recognized as a reptile or would have called a reptile to what we now recognize as mammals is actually an enormous collection of individual species that we have identified a myriad exchange for.
My niece, whom I interviewed, who's studying evolutionary biology, she mentioned a fishapod. That's not the technical word, but do you know what she's talking about?
Yes, that would be my favorite area of our evolution, which is actually in some senses more interesting than Permian therapsids. That's going just before that to the Devonian period. And there are things like Acanthus stegogonare is my favorite transitional species ever. If you've ever seen the emblem of the Darwin fish, the fish symbol with feet.
Oh, yeah.
Yeah, this is that. That is this is that thing. It had legs with toes and elbows and wrists and all of that, but it's a fish. And it's not even just a fish. It's a fish. It's a salamander that is a fish. But it's not really a salamander, but it's a perfect transition. It still has internal gills, and it walks, although it doesn't walk on land. This is something that a lot of people would immediately discard that's a salamander, except that it doesn't have the external gills like some salamander larvae have. This has internal gills with gill bars. So it is still a true fish. It's just a true fish with legs, complete with elbows, wrists, and fingers.
All it's missing is his iPhone. But I'm wondering about the nomenclature. Is there enough room in the language to accommodate all the new species, or do we have to make longer and longer and longer names for each clade and each species? How does the nomenclature work? Is there a way of accommodating all the new stuff?
Carolus Linnaeus devised a binomial system of nomenclature, but of course he didn't know that evolution was a thing. He couldn't figure out why it was. When he was trying to build this classification system, he was fully expecting that he was going to resolve created kinds. And what he found instead was that everything was daughter sets within a sequence of parental or ancestral sets, like a line of Matryoshka dolls, except that every Russian doll that you open doesn't have one doll in it. It has two or four. Okay, so just imagine how that diversifies. So he realizes everything goes in these parent categories. Multiple things go into a parent category together, and then multiple parents of that go into a parent category together again. Creationism could not explain or account for that. So Linnaeus was left in a quandary, especially when he tried to classify chimpanzees and orangutans. They didn't know about gorillas yet, but they knew about chimpanzees and orangutans. And when he tried to classify those, he classified them as people. And he made a public post challenging the scientific community to point out the difference, because he said there wasn't one. There was not a difference to distinguish humans from apes or apes from humans. Now, he had no idea about evolution. It couldn't make any sense to him. And we can't say that chimpanzees are humans or that orangutans are humans, although he classified them as such. The way that it works with this series of Russian dolls that we were talking about is that chimpanzees and orangutans and gorillas and gibbons and humans and australopiths and a number of other things all fit into the parent category of apes. And then, within all of us within that parent category, that makes sense, but he wasn't able to figure that out.
What is a primate, technically speaking?
A primate is a specific type of mammal, boreoeutherian mammal, that has protective bars around the eyes. Whereas if you look at a dog's skull, you'll see that there's a little recess where their eyeball fits into, but it doesn't have a frame around it. So if you were to hit a dog on the side of the head, you would damage its eye. But primates, the most basal primates, all have this bar. And our eyes are oriented forward also, so that it's binocular vision. We don't have primates that have their eyes pointed out to the side because we have to navigate through trees. We need depth perception. That's our biggest deal. So our eyes have to be oriented forward. We have to have color vision. And so all of these traits built onto a particular subset of mammals.
Oh, so it's all about the head. It's nothing to do with their dragging their knuckles on the ground or not.
What all primates also have opposable thumbs.
Okay.
So there are post-cranial traits as well. These are just the most obvious ones. And honestly, if I were to go through the full list for each category, they get Yeah, I'd be speaking Latin.
Yeah. So back to the question about the classification and the nomenclature. Is it getting cumbersome, or is there a way to keep the names short with every new discovery?
Oh yeah, we keep the names short just as a matter of tradition. So everything has the genus name and the species name, but then we get to certain peculiarities when we get to these end nodes where we know that things are still evolving. So like Canis familiaris, the old name for dog. Well, now dogs have been reclassified as wolves, so Canis lupus familiaris. But now we know that we have other subvarieties that may become species unto themselves. And so we may have Canis lupus familiaris dachshund. But our tradition still is to keep it binomial. There are some instances where the tradition is actually changing to a trinomial system, but we're not going to do four names together. We would simply drop off the genus Canis if we needed to. If we're going to, we would identify, or keep the genus and drop everything else between that and dachshund, for example. Canis dachshund would be the easiest way of putting that.
I see. Do you know anything about the Dewey Decimal System in library science?
I know that it exists.
But they do have to try to break down in these sort of family trees, like a broad category and then narrower categories and then narrower categories. And I've always been fascinated with that. Like there must be some problems there that are unresolvable where they have to just compromise and say, look, I know it's not a perfect fit and you could make an argument for this other category, but I'm going with this classification. Is it the same thing with phylogeny?
There are arguments in phylogeny, but there's ways of solving them. So I don't know what the issue with the Dewey Decimal System is, but I mean, the more you study anything, doesn't matter what it is, the more you study it, the more complex it's going to turn out to be. The more you know about it, the more nuances there are. And so everything is going to break down into where there's some inconsistency somewhere, though I can't at the moment think of what that would be here.
You couldn't think of a case where there's a fish dog and a dogfish, and you're not sure if the fish dog should go under the dogs or the dogfish should go under the fish. You know what I mean?
A dogfish is a subset of sharks.
I'm just being silly, but you know what I mean, right? Like,
and a catfish obviously has no determinable relationship to a cat.
Yeah.
A lionfish is not related to a lion. So.
But you know what I mean, right? Like there might be these ideas where there are a whole bunch of things in common between these two seemingly unrelated branches, but we could make a case to place it either way.
Okay, well, I can give you a couple of examples where that has happened. So once upon a time, they had aardvarks and anteaters and pangolins. And they classified them all together based on the criteria that all of them lost their teeth. Now, losing teeth completely, being toothless, and having to eat ants is a kind of devastating change. So it was assumed that this must have only happened once. And then from that, you have these three different types that diverge away from there. But the genome came back and said, no, that's not the case. Genetically, it turns out that pangolins are more closely related to carnivores. Aardvarks are more closely related to elephants, being Afrotherians. And Xenarthra, which is the anteaters, the South American anteaters, or the South American... Xenarthra is a collection of anteaters and armadillos and sloths. So the South American fauna all have a genetic link, and it had nothing to do with that. They all, in other words, the three groups lost their teeth independently, and all coincidentally began eating ants. Because that's what you would do when you lose all your teeth.
I always pictured ants as being crunchy, but I guess they'll never find out.
Yeah, exactly.
What about transhumanism? Are you excited about it? Do you think it's a good, worthwhile project?
Well, I have to know what you're talking about because I have seen different definitions. What I mean by transhumanism is where we can take control of our own evolution, which is a good thing, definitely. Yeah, some people will look at the movie Gattaca and they will think that that's a terror story or that that's a horror story, whatever you want to call it. But I don't look at it that way. We are already controlling our genes as much as we can. We figured out there's the PAX9 mutation, for example, which has a high proclivity among Mexicans. Mexicans have a high rate of anagenesis through the PAX9, which means that they don't, this is not all Mexicans, obviously, because there's a huge range, but in the sampled set of 100 people, they got 100% of the sample had anagenesis of the wisdom tooth. So they didn't grow wisdom teeth, the third molar, which means that they didn't suffer the morbidity of impacted wisdom teeth. Now, if we could transmit that mutation to every developing human, nobody would ever have impacted wisdom teeth. We have the same number of teeth as chimpanzees and gorillas, but we don't have as big a jaw as they do. And the problem with that is that third wisdom tooth, when it comes in, it's the only monophodont tooth that we have. It's the only one that isn't, that doesn't grow and replace. It comes in once, and it comes in late in life. And when it does, it usually comes in at an angle because of the position of our jaw. So it comes in and impacts everything else. There are a handful of positive mutations that we can find in certain people. And if we can extract them and put them in other developing people, that would be advantageous. That'd be great. I know somebody who has multiple, I can't remember what the name is, at aorta. I don't know. He's got something in his heart that even though he weighs 600 pounds, he's never going to die of a heart attack because he has this second tube in his heart. He has a duplicate tube. So it can't kill him. He could have a complete closure of one and he's still fine. So if we could take a mutation like that and put that in our developing children, that's excellent, right?
Yeah. We come from like some sort of rat-like mammal. Is that true? Like a squirrel or something like that?
Okay, the base template for the simplest that mammals can get are, if you look at a rat, that's one example. Another one would be a shrew. Another one would be a possum. Like, now, possums are marsupials, right? And shrews are placentals. But if you look at the two of them, they look pretty much like each other. And a rat has actually a number of specializations. They've lost their thumb, which is really unfortunate because otherwise they would be using their hands. The rats and humans actually have like hundreds of codons at a time that are in perfect synchronicity. It's unfortunate that they've lost their thumbs. And they've also lost their canines, whereas shrews still have their full complement of teeth, and that makes them more generalized. They're more capable of adapting to a number of different varieties, where rats are now somewhat limited. But if you take a marsupial, the possum, and the shrew, now you have the most generalized mammal form there is.
Okay, so if we go back, how many like clade branches back is that to get from us to that primitive form of mammal?
Let me see. The number's not going to be exact without having to look up my notes, but I would say that's going to be right around 35.
Wow, that's a lot. So if we could go another 35 into the future, is it reasonable to expect that we will be to that future evolved thing as the rat is to us, like in that distance in terms of sophistication, intelligence, and the advantages we have over these little mammals? Would there be that necessarily that jump ahead in sophistication and evolution? Do you think that's possible?
Well, we have the advantage of we're still very generalized. We are still anthroposaur because we still have 5 digits on all 4 appendages. We still have all 4 appendages. So we still have cuspids and canines and molars. We still have the variation of teeth. We have a lot. The one thing we missing that a lot of other animals have that we no longer do is our tail. And that has been in some lineages bad. Because if you have the tail, then you have something you can adapt for other purposes. And so the more things that you have that you can adapt for other purposes, the better. The more specialized you are, the more painted into a corner you can be when the environment changes. So the big-brained animals are us, parrots and crows, elephants, pigs, dolphins, and whales. So dolphins and whales, huge brain capacity. They have comprehension of language. They can see in color. They have brilliant aptitudes and all these different things. They could be us, but they have no hands. And they live in an environment where it's impossible to sculpt anything or to build fire. They can't create chemical composite. They can't do chemistry. They can't make tools. They can do nothing. They've gotten the super brain. They can't use it. How pathetic is that? Now look at the elephants. Elephants also have a huge brain. They have phenomenal capacity for comprehension. But again, imagine you have one hand and that one hand has 2 fingers and that's it. I mean, this is what an elephant can do with its trunk, right? What can you do? It's very, very little. The elephant is incapacitated by its own physiognomy. There's nothing that an elephant can do to expand on that intelligence. And then we have parrots and crows. They have to stand on one foot in order to hold anything in the other foot because their arms have turned into wings and they can't reach. While they still have fused fingers in their wings, they can't separate those fingers. They can't adapt hands out of them again. So they are so specialized that they are doomed. They can only go this way now. They don't have the course to take that other path anymore.
Okay. This is a good concept you've given me now about this generalized versus a specialized state. Okay, that's a new thing. I hadn't learned about that yet, so thank you for that.
And my favorite example of that is the raccoon. Raccoons have, like we do, are procyonids, which means that they're basal to dogs. They are karyotypic of what dogs and bears and weasels all stem from. So the ancestor of all these things looked very much like a raccoon. Coincidentally, and I was talking to a geneticist about this a few years ago, I said, why is it that raccoons, unlike everything else, when we have two species of raccoon, we got one in South America and one species for the entire northern hemisphere. That's it. I mean, raccoons in the United States are the same as raccoons in Russia. They're the same damn species. Why is there no diversification? There should be. And this geneticist said they'd actually studied raccoons, and they found out that their mutation rate or their evolution is extremely slow. So they actually have a number of species that effectively don't evolve, or that they evolve so slowly that it just doesn't happen in a way that, I mean, these guys have been 10 million years virtually identical to what they are. But they have, like we do, they have these wrists that will twist, and they have hands. They have actual hands where they can hold things. They can pick up things with their hands and walk around with those things in their hands. But the two disadvantages that they have is, one, they have such a slowed mutation rate that they don't evolve effectively. And two, they don't have the brain that the crow or the parrot or the elephant or the pig. Can you imagine? Look what a pig can do. It's got hooves. Can't do a damn thing. Right? It can't manipulate its environment. There's no way it can learn. There's no way it can better itself as a population. But raccoons have all of that. They just didn't get the brain.
That's funny. There was a raccoon eating our garbage the other day.
Yeah. Yeah. So you're looking at this animal. You have all of the physical aptitude you need to be anything you want to be. It's just that the brain you should have went into something else that can't use it.
Could they give them a brain transplant from a raven?
No, because ravens have dinosaur brains, which is basically a reptilian brain, which means that you have almost no cerebral cortex. They have a bird's brain is a hyper-tuned reptile brain. Imagine it's like if we went back to the 60s and you were like comparing American and European cars. And the European engine would be much, much smaller than the American engine, but it's got all of these things to tune it up, and the turbochargers and the superchargers and all of they've done everything that they can to get all the power they can out of that tiny little motor. And that's the way bird brains are. They are hyper advanced. They're super developed, but they're not big.
Who are the candidates today that are alive today? The candidates for an exciting future in terms of evolving into something bigger and better and smarter and faster and all that?
That would be a tough choice. I mean, like I said, my first option would be raccoons, and there are others that are unfortunately going extinct as we speak that had this other ability, like red pandas. And these are things that are generalized enough that if they could speed up their evolution a bit and take advantage of this environment, I would think that raccoons just living where they do, if all people dropped off the planet, the raccoons would be the best suited ones to take over. But with that stupidly slow mutation rate, it's not likely to happen.
How does something, for example, get wings? Let's say we wanted this raccoon over millions or billions of years to eventually have wings. Could we, in a thought experiment, could we set up an environment where there's an incentive for him to grow his wings and to fly? Just in a thought experiment, could you talk me through how that might happen?
It stuns me that you even have that concept. It's bewildering to me. I mean, I've always understood evolution. Ever since I was a little kid, I've always understood evolution. And the reason that I did was because somebody gave me a diagram when I was in second grade. They gave me a diagram on taxonomy, and that's it. That taxonomy is the biggest explanation for this. So for anybody listening, if you're curious at all, if you sincerely want to understand what we actually know about this, please watch my series on the systematic classification of life. I'm working on episode 40 right now. And so that'll be up in the next couple of days. But this will explain our molecules to man, all of it. Okay. But now when you're talking about growing wings, let's look at the times that wings have grown before. We talk about insects, because insect wings started from the opening part of the carapace, which I'm guessing you don't care about that. Dinosaur wings, which is where we get birds from. Is that the one you want to know about? Or are we going to talk about mammals? Because mammals have only two types of flight. What one is flying, one is gliding.
Like the squirrel?
Squirrels, phalangers, and colugos.
Okay. Now let's talk about birds. Like, what was the precursor to the bird, and how did it learn how to fly?
Okay. Early dinosaurs, they were hind leg dominant. Many of them had to go bipedal because their hind legs grew so outrageously large. They used they're called manoraptors. It's a certain subset of theropods that have grabbing hands. So now they reduced their fingers. They all started out with 5, and we have early dinosaurs that have 5 fingers, but most of them lost the thumb and the pinky, so that we end up with 3 fingers. And those 3 fingers are grabbing fingers. And the velociraptor, which is a famous example of this, we know from the skeleton how its arms could retract back and do a grab, which exactly duplicates a flapping motion. Now, what we found out after that was that velociraptors are not at all what we thought they looked like in Jurassic Park. Velociraptors were fully feathered. Now, we've seen the evolution of feathers in a number of primitive dinosaurs that are older than that. We've seen how early dinosaurs had something along the lines of like a downy kind of covering, like a fluff, and these turn into something that would be similar to emu feathers. If I don't know if you've ever seen emus, their feathers are very, very primitive. They're not asymmetrical. They're symmetrical. They're not like flight feathers at all. They're almost like hair, with spines down the middle and then offshoots off of those spines. So very primitive type of feathers. And then an emu gives a good explanation of that, because if you ever get a hold of an emu, and I had a pet emu for a number of weeks, I absolutely loved that bird. It was my favorite pet ever. I had a 6'6" tall emu living in my backyard for 3 years. And I would take him for walks at the park and everything. I really loved that bird. But when you examine the emu, you realize that while you can't see its arms, it actually does have arms under those big shaggy feathers. And it has a little elbow and a wrist and a single finger, one finger. And on the end of that finger is a claw. The interesting thing about that is that there's no musculature in those arms anymore. None. So they're tiny. If you've seen a Tyrannosaurus Rex, everybody makes fun of how tiny its arms are.
Yeah.
That's an emu. Emus have really tiny arms. They literally can't do anything. They have no musculature. So why the hell does it have a claw? It can't use the claw. It can't move its arm. So when people tell you, when the other creationists tell you there's no such thing as a vestigial trait, you can say, you are lying to me, because we do have claws on the ends of the fingers of emus, and that is a vestigial trait. That is a dinosaur arm that does not serve as a wing. So with velociraptors, though, velociraptors had wing feathers, albeit short ones. And the reason that they had them was maybe initially for sexual display, but it ended up having an alternate purpose, because when you have these short wing feathers, the half wing that many creationists say that you can never find a half a wing, but yeah, we do. We got lots of them, actually. And half wings are very useful because you can incubate a much larger clutch of eggs, which produces a very strong selective pressure. The ones that had those wings, that they had the wing feathers, had more babies than the other ones did. They were able to incubate a larger clutch. They were able to provide better than the smaller ones. Now, remember also that dinosaurs have hollow bones. They can breathe through their bones. It's connected through a system of lung sacs and everything. They have a much, much more efficient respiratory system than any mammal, which is one of the reasons that dinosaurs got so stupendously big, because they could process oxygen way more efficiently than we do. Any dinosaur the size of an elephant is going to be pound for pound faster and stronger and more efficient than an elephant. An elephant doesn't stand a chance against any kind of dinosaur the same size. Any mammal versus any dinosaur, the dinosaur is more efficient. It's better built than the mammals are. The reason that we survived and they didn't was because our ancestors at the time that the comet came down were living underground and were very small with tiny food requirements, whereas dinosaurs ran a gamut. and they were very susceptible, and they laid eggs, whereas we were able to contain ours.
What sort of growth would there be, like in terms of these mutations giving beneficial changes that make them more fit for survival?
I don't know what you mean.
Well, when I talked to my niece, she said that eventually some of the fish wanted to stick their head out of the water and look around, and so they started developing necks so they could turn their neck without turning their whole body.
There is an advantage in when we see this with some animals that we still have. Like I had another one of my pets was a bichir, also known as a Senegal, a Polypterus senegalis. And this is a fish that is very close to the Devonian lobefin fish. As a matter of fact, it has legs on the front. It doesn't have elbows or any of the rest of that. It just has the legs. And because of its early diversion from everything else, it has much less calcium in its skeleton than other fish do. So it's much closer. Its lineage originated much closer to the split between cartilaginous fish and osteichthyes, or bony fish. So the common ancestor there, one of these fish start containing more and more calcium to strengthen their bones. And the stronger bone isn't as flexible, which is why there's an advantage to sharks having cartilaginous skeletons. But then there was these osteichthyes that developed heavier, stronger, and more brittle bones.
Can you just give me an example of a fish that I might have eaten from each category, the hard-boned one and the cartilage one, please?
I don't know if you've ever eaten shark.
Yeah, I've had that.
Okay, well, that's cartilaginous. That has a cartilaginous skeleton. It has no bones in it except for its teeth.
Oh, and all the other fish I've eaten, like tuna, it's all bony?
Yeah, those are teleos. They're all osteichthyes. They're bony fish. And then when you get into freshwater areas in the Devonian period, for example, now you have murky, very often muddy, low visibility areas where these fish will have a difficult time swimming, but they can creep around in the narrows of rivers and such. And so there's an advantage in being able to peer out of water, as very few fish do. Very few fish now will raise their eyes out of water just to get a better vision about what's around them. Fish that have legs or have any adaptation for legs, like the fish that I'm talking about, this is a freshwater fish, comes from Africa, the Polypterus senegalis. It uses its legs to hold still on the bottom so that its prey doesn't see it. And it also has a very primitive lung with an asymmetric lung growing out of the side of it, which of course these will balance out geologically. We show how both of these lung sacs, or what is originally a buoyancy bladder, separate into two even ones, where in Senegals they're still asymmetrical. So this fish doesn't need the gills. It fits in warm water and it's stagnant water. There's no oxygen in that water, so normal fish would have drowned, literally. But Polypterus senegalis and all of these others, they can sit in these shallows, in these warm shallows, and they can just go take a gulp of air whenever they need one, and then go back to the bottom. They're literally breathing.
That's pretty wild. Yeah. So can you talk me through that particular example, because that sounds interesting. How much time would it have taken for it to go from what it was before it could breathe air until what it is today, where it can stick its head out and breathe air? Can you paint a picture?
We're trying to pick an almost arbitrary stage between one period of development to another period of development. So you're talking about somewhere between 400 and 320 million years of, and this again is off the top of my head. So what we have throughout that entire interim is things like Polypterus, which is a living fossil in the sense that it's karyotypic of those early adaptations, because there's no direction, there's no plan. Evolution tries every experiment and keeps running even failed experiments with the new set all the time. And some things have an advantage and some things, don't work out. So these the Polypterus are meat eaters. So if you ever had one in your fish tank, you wouldn't want to have any other fish in there that you cared about, because it will eat them all. So this thing will sit on the bottom and wait till something gets too close, and then suddenly use those little legs in the front to just dart forward and gulp whatever else it is. So they can be fascinating. They look more like snakes or lizards than they do like fish. It's kind of fascinating looking, because the head looks very much like a colubrid snake. Although they are not snakeheads and shouldn't be confused with snakeheads. Snakeheads are named for some other arbitrary reason, but the Polypterus actually looks like it has a more snake-like head. They're fascinating fish. The first time I saw one, I remember being stunned as I looked at it, because this is a fish that is a lizard. This is a lizard fish. And so, of course, I bought him and I named him Darwin. and I had him for 11 years.
So if you do discover a new species, would you get to give the name also?
Hopefully.
Do you have a name picked out?
Covfefe.
Does that mean something?
No, not at all.
Just sounds good.
It's what Donald Trump was when he was trying to say coverage, and he fell asleep while he was tweeting. And then because he's so narcissistic, he can never admit that he's ever made a mistake, so he has to lie about everything, and then said that, oh yeah, there's a few people in my cabinet who know what Covfefe means. Yeah, bullshit, they do. But I mean, that's if I were to find something that is not already distinct in some other way.
Who keeps track of all these discoveries? Because it seems like, with calculus, there was Leibniz and Newton, and they both discovered the same thing. Who keeps track of all that?
I don't know what you mean by who keeps track. I mean, there's the peer review process where you have to publish your findings.
Yeah, so that's what you would do?
Yeah, and it takes a great long time. And like when you see in the news that the scientists have discovered X, it's not like they pulled it out of the ground last week. Okay, so they pulled that, whatever that is, they pulled it out of the ground a decade ago.
Oh.
And they've been spending the last 10 years removing it from the matrix. I was given a tour of the Royal Tyrrell Museum in Alberta, which is a fantastic museum. And I was given a private tour of their labs and their storage facility in the back, because their director had something he was very proud of, and rightfully so. He had the absolute best dinosaur fossil that had ever been discovered by anyone ever in history, and it hadn't yet been released to the public. So I was allowed to walk up to this thing. I didn't show the disrespect of touching it, but I could have touched it if I wanted to. It was exquisite. This was an ankylosaur that I guess it got caught in a tsunami or something, but I mean, this was a very rare find where we end up with a dinosaur that has mummified. It is both inundated with water and buried at the same time, which almost never happens. And it was buried so perfectly that you have a perfect impression of its skin, not its bones, its skin, and not just the skin, but encased the way it was when it was alive. So what they finally released this thing, and they show the exhibit of this ankylosaur a year or two after that. But I mean, I'd already seen it 2 years before it became public.
Wow.
Yeah, and it was exquisite. I mean, so beautiful. When you get up close to it, it's like the fossil itself was black, and the matrix was a much lighter color. So they were still using these painstaking tools to take little by little, take out the rock that surrounded the fossil to separate them. So there's ankylosaur that they have this beautiful image that shows a skin pattern that is what you would see from an alligator. Those fine details of anything of a dinosaur that looked so much alive as this.
Wow.
It was really magnificent.
So the difficulty I have is understanding how microscopic and very slow changes give any sort of benefit to the offspring that are manifesting these mutations. Like,
I don't understand.
Well, like, I mean, the basic principle, as far as I've understood it, is that there are random mutations, and these provoke changes in morphology or whatever the case may be. And then that becomes an advantage, and then so that one survives, and the less efficient ones don't survive.
Well, let's simplify this a little bit. Evolution at every level is a matter of incremental, superficial, usually subtle changes in proportion, whether it's chemical or morphological. So it's just a small change in proportion. And then this variation happens all the time. Every sibling is ever so slightly different than other siblings. Now, sometimes those will be accentuated. Sometimes there's, a different coloration or a different size or a different size of a particular proportion, like larger front feet than back feet, or most typically larger back legs than front legs, something like this. And then eventually one of these adaptations is beneficial. And then you have a whole new lineage that diversifies from that. For example, look at praying mantis. Praying mantis is effectively a cockroach. A praying mantis is a cockroach with two important mutations in it. One is the separation of the thorax, so that it's now running on four legs, but it has its front legs free. And the other advantage is that the front legs become grasping legs. That's it. Otherwise, that's a cockroach running on 4 legs. But look, you've got tens of thousands of species of praying mantis. I don't know how many documented species of praying mantis we have alive right now, but I mean, there's hundreds of them, right? As with cockroaches. You look at the huge diversity of cockroaches. None of them ever had a natural selective advantage, unless it's their ability to ingest and survive poison, things like that. Obviously, there's some advantage to that. But when you get this one where suddenly you've got this crook in the back, and got one cockroach that doesn't use its front legs for walking, it actually uses it to grab other things. And now it's a specialized meat eater. And now you've got thousands of new species based on this one change.
You know that image they have of the primate that's becoming erect over a series of images? You know that typical image?
Yeah, Rudy Zellinger's painting, which confuses a lot of people. It is an iconic image, and I understand what he was trying to illustrate, but people would find literal issues with that. I mean,
Okay.
Because he's taking things that existed at the same time and putting them in a sequence. Australopithecus did live after Ardipithecus, but Neanderthals and Denisovans and Homo sapiens, Homo erectus, there's a point when we all lived at the same time, when all 4 of those were alive at the same time.
So it's a little bit misleading, that icon?
To put them all in linear like that, because what it implies in Zullinger's painting is that Homo sapiens descend from Homo neanderthalensis, but we know that's not the case.
Could you illustrate one that's more accurate?
From Homo erectus, we know that all living people now descend from Homo erectus. There was one that went extinct 13,000 years ago that was not descended from Homo erectus, and then arguably wouldn't be human unless our human classification includes Australopithecines, because there's one, the Homo floresiensis, has a couple of traits that were taken from Australopiths that didn't exist in Homo erectus. So we know that they'd actually broke off earlier. But Homo erectus is the base template for Homo heidelbergensis, which then produced Neanderthals on one side, sapiens on the other. And now we know of 2 other human subsets. They are the Denisovans, and one for which we've still never found any fossil record. We've identified it in genes. There's a group of people in, I think it's Melanesia, that they've identified a genetic trace for another as yet undiscovered human race. So that would be 4 of them.
Most people would agree that humans are special, that that's sort of the top of the heap, the pinnacle of evolution and this sort of thing.
Yeah, we're the most arrogant. I mean, we're the only animals that were so arrogant that we called ourselves the wise. Man the wise. And then what do? Burn up our own planet. Yeah, we're brilliant.
Can you talk about the sort of relative value? Is there an objective value hierarchy, or
what are you talking about?
I'm talking about like that image, that iconic image where you have this primate that's slowly becoming erect. It sort of gives the impression like this is good, this is better, this is even better, and then wow, today we're like amazing.
Are dolphins not amazing?
Yeah, of course they are. Yeah.
Okay, but they're not even in that lineage, right? Elephants are amazing.
Yeah.
Right. I mean, I can be very much impressed by any number of things. I mean, what makes humans distinct? We're the only animal that got the big brain and the raccoon body. We got the generalized body that can do stuff. We're the only ones that got the brain and the body together. Everybody else got cheated by getting one or the other, which is pointless and stupid. Why would you have the ability to walk around and twist your wrists and grab things and carry things in your hands and you got a dog brain and that's it? I mean, talk about a lack of intelligent design.
So, do you agree that we are the most exciting animals on the planet, or no?
Are we the most exciting?
Yeah.
We're the cruelest. We're the most conceited. We are the ones that we are, for the first time ever, for the first time in geologic history of this planet, a single species is the cause of an entire extinction level event. And it is one of the biggest extinction level events ever. the Anthropocene extinction, which is being caused by humans right now, is predicted to cause the extinction of saltwater fish by 2048. That's this century, potentially within my lifetime. We could have no more saltwater fish because of what we're doing, because of the industrial level that which we're fishing out the ocean. So that's just one of dozens of horror stories I could say about what we are doing to the planet. So we're going to have to redefine what exciting means.
So you don't give us pride of place in any hierarchy whatsoever.
We have potential, yeah, but we have equal potential. We have more potential to do harm than anything else, and we are doing that harm.
So, like, you know how we have pets and we farm animals for food.
Mm-hmm.
What would you think of the idea of in the future if some more evolved animals took us as pets and cultivated us as a food source?
Well, it would be just desserts, literally, wouldn't it? But what I'm hoping about, and I think you mentioned transhumanism, is there's another element to just beyond controlling our own genetics. We have the ability now to do something that no other mammal has been able to do. Certainly, we have the ability now to go beyond what humanity could ever do. You remember in The Matrix when they're all eating that goop?
Not really.
Okay, well, there was a movie called The Matrix. You've seen The Matrix, right?
Yeah, I just don't have a good memory.
Okay, well, so they have to eat this like soup that they make, and it has everything that they need, supposedly, and they have to eat that soup every day because that's all they have. But we have the ability now to create our own, literally build our own food, and not just lab-grown meat. I mean, we can actually go beyond that. We now have the ability of creating our own cake or paste or meat patty, or we can do a variety. We don't have to do like they did in The Matrix and always have this goopy soup. We can do different types, flavored and enhanced in a number of different ways, to where we can do this without any animal expenditures at all.
Are you vegetarian or vegan or anything like that?
I would like to say that I have to admit that I'm a huge hypocrite in that I ever eat meat at all. I enjoy it. Nothing ever tasted as good. But I have to concede that if you're a vegetarian, you will lose weight, because when nothing tastes good anymore, you won't eat as much.
Yeah, but I know you enjoy eating. You told me that last time.
Yeah, I do. But I'm seriously considering that I have to make that transition. It is already the case that when we buy meat, more often than not, we buy cruelty-free.
Okay.
Yeah.
And have you ever had a really, really tasty vegetarian dish?
There's no such thing. I did go recently. We had an atheist conference here in Dallas, and there is a Krishna temple here in Dallas that has a really excellent vegetarian restaurant in it. And so I managed to get a party of 25 of our atheist speakers from other countries and other states to come and have a communal dinner there. And they all said it was as the British kids put it, it's brilliant. So we had a number of vegetarians in the troupe, and they all appreciated the food. And that time it wasn't bad. The first time I had a vegetarian meal, it wasn't good.
Yeah. No, there's good stuff to be had. I think you just need to get used to it and try mixing up the flavors. And, you know, I think spice and seasoning really makes a difference, right?
Yeah, I know how bad it is to have exponential human growth and be eating fish at the rate that we are, to be eating any animal at the rate that we are. We're not going to. I've eaten crickets a number of times, but I mean, we can't really shift over to crickets. It is possible to sustain the entire population on a vegetarian diet.
Yeah.
I can't say vegan because I don't know how we could live without butter or milk. I mean, because that's part of everything.
Yeah.
All right. I'm going to have to let you go because
thank you so much.
I have an errand that I'm going to have to run, and I'm sorry that I'm going to have to duck out. This has been a fun conversation.
Yeah. Thank you very much. I appreciate it. Have fun. Take care. Eh?
Thank you.
Bye.
Bye-bye.
If you like your worldview, if you think it's swell, if you've got some questions, ask me and I'll tell. All you got to do is ask. All you got to do is ask.